In the last lecture, we have studied the method so-called northwest corner method. We have seen in that method we are not using any approach of the transportation cost. Today, and hence in that method we cannot reach to near to the optimal solution. Today in this lecture, we will see to relate the solution with the transportation cost also. So here is the method. First of all, let us recall the northwest corner method. So let's see one example here. Simply, I am assuming that we are having sources A, B, and C, and the destinations we are having named A, B, C, X, Y, Z. So X, Y, and Z. Let the transportation cost table is as here. From A to X, the transportation cost is say 15 unit. Here, A to Y transportation cost is 10 unit, and A to Z transportation cost is 5 unit. B to X, the transportation cost is 6 unit. B to Y transportation cost is 9 unit. B to Z transportation cost is 13 unit. C to X transportation cost is 5 unit. C to Y transportation cost 4 unit, and C to Z transportation cost is 15 unit. Let be this way. And at A, the production is given as here say it is 10 unit, here it is 15 unit, and here it is 20 unit. So total production we are having is 45 unit. And here say requirement of X, Y, and Z respectively are say here it is 11, sorry, 12 unit, here say it is 13 unit, so this is 25, and here say it is 20. So if we apply the northwest corner method, then here minimum of 12 and 10, so here it will be 12, so 10, so here it will be 0, and here we are left with 2, so this row is cancelled. Then we go for this left table. So here this is the northwest corner, and minimum of 2 and 15. So here it is 2. So here we are left with 0, and here we are left with 13. So again this is done. So this column is removed. Now we are having this as a northwest corner, minimum of 13 and 13, it is 13. So here we are having 0, here also we are having 0. So this column and this row both are cancelled. And here we are having 20 both sides. So minimum is 20, 20. So here we have 0 and 0. Means this is our table, and this way we are transporting. So let's calculate the transportation cost corresponding to that. So transportation cost is here we are A to X transportation cost is 15 unit, and we are transporting 10 units. So here we are having 10 times 15 plus here we are transporting 2 units, and transportation cost is 6. So 2 times 6 plus here transportation cost from B to Y is 9, and we are transporting 13 units. So 13 times 9 plus here from C to Z we are transporting 20 units. So 20 times 15. So this is our total transportation cost. If we will calculate it, it is 150 plus 12 plus 13 times 9. It is 117. So here we have 1. Is the mouse. So here it is 117 plus 20 times 15. So it is 300. So total sum is 300 plus 150. So 450. 450 plus 129. That is 975. So 579 rupees transaction cost is there. Okay. So we are having too much transportation cost even for the simpler problem. So let's go for the another method, so called row minima method. So we are starting with the row minima method. What is the row minima method? Actually, let me copy the table once again so I can continue with the same problem. So here is the copied last table. So I will now continue with the row minima method. What is the row minima method? Actually, in this first row, we will start with the first row of the table. So in this first row, select the minimum value, that is 5 here. So for that we will start the allocation. So here it is 10 and 20. So the minimum is 10. So we will transport 10 units from A to Z. Here we are left with 0 and here we are left with 10. So this row is removed because this is now 0. Okay. Now we will go towards the remain table. Again, this is our first row. So minimum of 12 and 15, minimum is 12. Minimum is, first of all, in this row, minimum is 6. Okay, so here I have to allocate. And then minimum of 12 and 15, so minimum is 12. So we are transporting 12 unit here. So here we are left with 0 and here we are left with 3. So this is 0, so corresponding column will be removed. Now we are left with this much table and this is our first row. So in first row minimum is 9, so at 9 minimum of 13 and 3, so it is 3. So we are transferring 3 units from here to here. So here we are left with 0 and here we are left with 10. So this is 0, so corresponding column will be removed. Now, sorry, row is will be removed, and now we are left with just this row. So here minimum is 4, so here we will transfer 10 units. And now we are left with 0, so this column is removed. Only one cell left. Here we are left with 10 units, so 10 and 10, so possibly scan. So this is the row minimum method. What we have done, and select the first row of the cost table. Select the minimum from that row. So here it is 15, 10 and 5. So minimum is 5. So we have selected 5. And then allocate whatever is possible. So here 10 and 20. So minimum is 10. So we have allocated 10. Continue this way till the end of the table. That is all the row minimum. Let's see what is the transportation cost related to this row minimum method. So the total transportation cost, let me write by analytically. So total transportation cost is here it is 10 times 5. Then here it is 12 times 6. Then here 3 times 9. Then here it is 10 times 4. Then here it is 10 times 15. So here it is 50 plus 72 plus 27 plus 40 plus 150. So the sum is 50 plus 70, so it is 1, 1, and 1, 2, 2, plus this is 67 plus 150. So 150 plus 1, 9, 5, 6, 11, plus 2 is 3, and 3. So here the transportation cost is 339. So comparative to the northwest corner method, we are in northwest corner method we are having 579, and in low minimum method we are having a transportation cost 339. So this is smaller than the previous. Okay. So better to go with the low minimum method than the transportation cost northwest corner method. Now we continue the similar process. Instead of row minimum method, we can go for the column minimum also. So let's start with the column minimum method. So for that, let me copy. First of all, I will write the column minimum method. So let me copy the whole table again. So after copying that, we are having. So here is the same table, I have copied it. Now, instead of going towards the rows minimum, we will just start with the columns minimum. So here is the first column and the minimum is 5. So here we will start the allocation. So minimum, sorry here it was 20. So minimum from 20 and 12. It is 12, so we will allocate 12 units here. So we are left with 0 unit here, and here we are left with 8 units. So since this is 0, this column is removed. Now we start with the remain table. So this is our remain table. Minimum from here it is 4. Sorry, first column is this. So here minimum is 4. So at 4 the allocation is possible from 13 and 8. The minimum is 8. So we will allocate 8 here. So here we are left with 5 units, and here we are left with 0 units. Okay. So this row will be removed. Now this is our again first column. So the minimum is 9, and from 15, sorry 5 and 15 minimum is 5. So we will allocate 5 units here. So we are left with 0 here and 10 units here. So since this is 0, this column is removed. Now we are left with only one table, sorry, one column. So minimum is 5, so first of all I will get 10, and 20 is minimum, that is 10 here, and 10, then this will be 0, and then here we are left with 10 units, so 10 and 10, so possible one here is 10. So we will allocate that here. Okay. So this is a column minimum method, means by column we will select the minimum value and then we'll allocate the corresponding values there. So we will select first column, then select the minimum from that column and allocate whatever is possible from here to here and here. So here it was 20 and 12, so minimum was 12, so we had allocated there. And then for the remainder table, since one row or column will be removed, then for the remainder table, continue the same process. Okay, at the end you will left with one solution to the given transportation problem. Okay, so again let's calculate the transportation cost due to this. So transportation cost is, here allocation is 12 times 5, so 12 times 5. Then here allocation is 5 times 9, so 5 times 9. Then allocation is 8 times 4, so 8 times 4. Then here allocation is 10 times 5, 10 times 5. And then here x is 10 times 30. So 12 times 5 is 60, plus 5 times 9 is 45, plus 8 times 4 is 32, 10 times 5 is 50, and here 130. So the sum is here it is 105 plus 82 plus 130. So 5, 6, 7, 3, 8, so 1, 1, 1, 3, 1, 7. So in the row minimum method and in the row column minimum method, there is no much large difference. So you can continue if you want, then you can continue with the row minimum method or column minimum method. Both are actually the same because if you will transport the matrix, this cost matrix, with the corresponding requirement and demand, the row minimum method will be converted to the column minimum method. So here, yeah, compared to the northwest corner method, we are getting more profit. Means we are removing the transportation cost too much large number in at least 200 rupees if it is in rupees. It may be in lakhs also. So compared to the northwest corner method, row minimum method and column minimum method are better. Okay. Still, we are having one more method, so-called table minimum method, or least cost method. This method is having same two names, table minimum method and called least cost method. Here, only difference is instead of thinking about row and column, you will continue with the tables minimum. So let me copy the table again so you can get that. Okay. So here I have copy pasted the table, whole table again, and now I start solving this problem. Means as a table minimum, and you can get that actually what is happening. So here, from the whole table we will select the minimum. So minimum is right now 4 in the whole transportation cost table. So there we will allocate the first possibility. So here minimum is from 13 and 20. So it is 13. So we will allocate 13 units here. Since it is 13, here we are left with 0 and here we are left with 7. So since this is 0, this column is removed. Now again the left table is with this column and this column. Here we are having two chances to select. Either we can go for this pile or this pile. So better is to go with where maximum allocation is possible. So here maximum allocation possible is 7 because minimum of 12 and 7 is 7. And here maximum allocation possible is from 10 and 20 it is 10. So we will go for this pile and the corresponding allocation we will write here. So we will transport from A to Z the 10 units. Okay, so here we are left with 10 units and here we are left with 0 unit. Since this is 0, the corresponding row will be removed. Now we are left with 1, 2, 3, 4 cells table. From that, minimum is 5. So now we will allocate whatever is possible, that is from 7 and 12, the possible allocation is 7. So we will allocate 7 here. So we are left with 0 here and we are left with 5 here. Now we are having only last row left with because this is 0, so this row is removed. Now we are left with 6 and 13, so minimum of 6 and 13 is 6. So we will allocate whatever is possible there, so it is 5. And Then we are left with here 0 and here we are left with 10. Then only one cell is left, that is 13, and minimum of 10 and 10, that is 10, so we will allocate 10 units there. So this is, now here we are left with 0 and here also we are left with 0. So this is another method to give a solution, feasible solution to the given given transportation problem. Let's calculate the transportation cost due to this also. So the total transportation cost is here 5 times 6, then here 7 times 5, then here 13 times 4, then here it is 10 times 13, and here it is 10 times 5. So this is 30, 35, 52, 130, and 50. So it is sum is 65 plus 182 plus 50. That is, here this two sum is 5 to 7. 5 plus 6 is 11 plus 8 is 9, 1, 2, 9, 7. So see, compared to the table minimum, row minimum method or column minimum method, see in the row minimum method, we were having transportation cost 339. In column minimum method, we are having transportation cost 317. While the table minimum method is having transportation cost 297. So in the table minimum method, we are getting less transportation cost. So this is our better uh, choice than the previous one. So if we are supposed to solve any transportation problem, then we can start with the table minimum method rather than going for the another row minimum method or column minimum method to get the initial basic feasible solution. Because as we closer to the original optimal solution, all we need is to minimize the transportation cost. Our main objective is minimizing transportation cost. So this table minimum method is far better than any other method as we have till seen. Also, I would like to explain, the allocations we have done in any method till now. So here, see in this problem, we were having allocation here 1, 2, 3, and 4. So since our problem is having 3 sources and 3 destinations, so 3 plus 3 minus 1 is 5, and we are having here allocation 4. Okay, if we go for this math problem, then we and this method, then we are having one allocation, second, third, fourth, and fifth. So 3 plus 3 minus 1, that is 5, that is matching here. In this problem also, we were having 1, 2, 3, 4, and 5. So here again 3 plus 3 minus 1, that is 5, is matching. So as I already have said, also in this method also, see 1, 2, 3, 4, and 5. So again 3 plus 3 minus 1, that is 5. Means as I have said that if you are having m sources and n destination, then m plus n minus 1 element will be in basis. So this is our basic zero solution also. Okay, we are going to see the proof of that theorem in later, but this is also our basic zero solution. So we can now from this we can start solving our transportation problem. As you know that the standard form of any transportation problem is minimize the transportation cost, that is summation I is equals to 1 to n, summation j is equals to 1 to n, x I j. This is the transportation done from I source to j destination, and the transportation cost. Let me write a I j. Okay. Then also the subject to constraints are, sorry, instead of AIG, let me write the transportation cost. So it is TIG. Better symbol is TIG. So let me write there TIG. And subject to constraints, summation of xij I is equals to 1 to n is bj, and summation xij I is equals to 1 to m is equals to ai. So here j is equals to 1 to m is ai, with of course your xi j's are equal to 0. Also, in the previous lecture, we have seen that this has feasible solution if and only if summation of I is equals to 1 to n is same as summation bj, j is equals to 1 to n. Okay, so using this standard form, in the next lecture we will see that actually the basis has have that m plus n minus 1 elements in basis. Means basic variables are these, means the variables which are non-zero is this. See here, here also that x11 is there, but x11's value is 0. Okay? So that's what I want to say. That the non-zero variables in basis are actually at most m plus n minus 1. That will be in our next upcoming lectures. Here. So you can try such more problems at your home. You can write any table. Let me write here for you A, B, C. Yeah, sources are 1, 2, 3, 4, and 5. Transportation cost and things I am writing. You solve it by all the possible methods we have been seen. Say the transportation problem cost is 5, 15, 13, 2, um, 2, 5, 6, 9, 3, 4, 1, 4, 3, 2, 5, and the cost, the production is, I am adding here, that is from A's production is say 10 units, from B's production is say 20 units, and from C production is say 30 units, so total production is 60, and here the requirements are 5, um, 15, so it is now 20, let me write here 12, 8, so it is again 20, 20, and here let me write again 20. So this sum is also 60. 20, 20, and 20. So it is 60. Okay, so you can have solve this problem by all methods, means north-west corner method, least cost method, then row minima method, column minima method, and for each evaluate the transportation cost. Okay, so this is your homework, and you can write more such problems on your own because you know now how to write problems. You are master in that. So you can write more such problems at your home and solve it by any appropriate method, and stay at home and stay safe. Thank you.